Okay then, let's get this thing started. Hello everyone, welcome to our latest webinar from StorMagic. Wherever you are in the world today, thank you for coming on and joining us, taking the time out of your day. It's great to have you on board with us today. My name is James Clark. As I said, I'm the marketing manager here at StorMagic, and I am going to be your host. Today's webinar, as the slide says, is titled Next Generation Encryption, and is provided today by ARIA Cybersecurity Solutions. It's going to provide you with a discussion on the evolution of the hardware security module, or HSM, and where this joint solution between ARIA, StorMagic, and HPE fits into that security landscape. With me today are Gary Southwell of ARIA and Dodson Dietrich of HPE, who are going to be taking you through the webinar today. They'll be talking to you shortly. With that said, I'm going to be quiet and I'm going to hand it over to Gary to take it away. Gary, it's all yours.
Thank you, and welcome to our webinar. I'll lead off and I'll let Dodson come in and talk to you a little about the HPE portion of the solution, which we're really excited to be working with them on. So with that, I'll cover these 4 sections here. We'll talk a little bit about key management and hardware security modules, or HSMs, the evolution, the need for a better approach. We'll then talk about our solutions, features, and benefits, some use cases, and then we'll open up for Q&A. I'll go quickly through some of the aspects of our product to make sure we're focusing on, the issues in the market today. But we can provide you plenty of additional details on our products if there's time at the end, or if there's questions regarding that. Okay, so with that, our offerings do try to span just about every type of deployment option we can think of that people have asked us for between the 3 vendors. So the simplest option many customers ask us for is there a way for me to get keys served to my applications so that my applications can encrypt on their own? And the answer is absolutely. We offer a cloud-based key management service that'll securely serve you keys to your applications. And that may be, all you need. But others are saying, well, I'd like to have control over generation of my own keys because that's a better form of security. I'm in control of my keys. I'm not relying on some third party. We give you that option as a software application. The SvKMS is an application you can run your own environment and then locally serve keys. It can run on any x86 server or VM environment you so choose. As we move up the stack, though, others will say, well, I'd like to make sure I can offer this more securely out of hardware. And we give you 2 options. One is to do just simple key management out of our hardware, which is the ARIA SmartNIC. And others are saying, well, I don't want to just do key management and serve keys to applications to encrypt. I'd like you to do the encryption securely inside your platform. And that's what our traditional HSM is all about. You send data in, out comes encrypted data. Everything's done nice and securely. And we give you 2 options to do that. We provide a SmartNIC approach to do that within your environment that takes up 0 footprint. But we also provide a full-blown appliance version with the highest level of security. And we'll talk quite a bit about that and why we chose HPE in their ProLiant series to be such a platform. So those are the 4 options. I won't talk a lot about them, but we will start to talk in a little bit about the challenges with the HSMs, which have been the hallmark of providing the best encryption security out there. But there are problems and challenges, and we've come out with an attempt to solve those challenges and provide a simpler approach to allowing people to adopt this level of encryption security across their environment. So with that said, if we look at hardware security modules, for those that are not as familiar with them, as I mentioned before, their primary function is to perform encryption. And they offload that encryption overhead from doing it inside the applications, and they do it safely and securely in hardware. That hardware is usually network connected and you send your application data to it. Typically, you're sending it to it in an encrypted payload. As it crosses the network, it decrypts the payload, runs through and encrypts the data, and then sends it back to you to wherever it needs to be stored or used in the future. It would then decrypt it for you and allow you to reuse that information to make updates. All right. So inside it, it's actually generating and storing the master keys. All right. Now, these HSMs have traditionally been single application focused, so they're tuned for a single application. And of course, they're hardware based, hence the name hardware security module. So in one way to kind of put pictures to what we just said, we have a picture here that shows a typical data center where you've got multiple of HSMs, depending on what your needs are. In many cases, you're trying to encrypt certain outputs of various applications. You may be trying to encrypt file data. Other cases, you're trying to encrypt, and this is often larger use cases, the actual data within databases. Or there's transactions. Typically, we think of retail transactions, that type of thing, where we're trying to encrypt that information and that data. But the HSM is basically there to do the encryption and decryption as you need it. So that's why you see people moving to a hardware-based option, because often these things are very time sensitive. They have low latency requirements so that the applications run effectively and quickly. And it really depends on the types of applications. In some cases, that's not a need, but in many cases, it really is. So that's another benefit of the hardware. The challenge is, though, if you look over time, HSMs have been out in the market for well over 15 years. When they were first offered, they were offered really by organizations that focused on getting the products out, and they provided people and professional services to help them integrate them to the applications within your environment, set them up, make them work. And then typically, as your applications went through revisions, things changed, you brought their pro services back in to deal with those necessary updates. So that created a bit of a cost challenge and something that had to be managed carefully, working with your suppliers. And also kind of locked in vendors, because that was a painful process to go in and pull that out and put something else in. So these are some of the real challenges you have. Again, the HSMs, though, for all their shortcomings in this environment, they've typically been more secure than your general purpose x86 environment, doing the encryption within it. And we've seen a lot of that, come out over the last 4 years, really, about all the vulnerabilities inside Intel x86 host environments. And that caused a lot of these issues. So people did say that, the HSM approach is probably the right way to go at large across, whatever server environment you may have. And this happens to include all the cloud environments, because there you really don't know what you're running on. And so it's actually encouraged there as well to have some form of hardware encryption. We'll cover that with bring your own encryption and some of the other use cases here as we go forward here. HPE's work, by the way, to help solve some of these problems, and we're happy to have that within our portfolio. But I also mentioned the need to encrypt, to send it to the HSM across the network, decrypt that, encrypt the application, and deal with those encryption, decryptions, multiple operations, which add cost and complexity to actually getting these things set up. So what problems are we trying to solve? We're trying to make the HSM a little bit more flexible and a little bit, or not a little bit, a lot easier to deploy inside your environments. So we're proposing, as I said, 2 versions here. One will be, I'm getting ahead of myself here, but PCIe small form factor SmartNIC that can go inside, any server that you may have. That starts to give you a lot of flexibility, and it can deal with multiple applications. It's not just a single application. And we purposely worked with StorMagic to make sure the software applications that we're using solve a lot of the problems. They're make it very easy to take upgrades, remove the need to have very difficult configurations. These things can be actually, we have a video of this on our site where we go and set up key management for a VMware environment. You can literally do it in 4 minutes, and you don't have to have any special training. So, those are the things that we really have focused on to make it a lot easier to solve those types of problems. And then there's the expense of the solutions, and then the difficulty making them scale. And again, we've addressed that, and we'll talk a little bit more as we go. So, what is a microHSM? Well, this, as I said, is a smart NIC network interface card that goes in PCIe slots. And we've engineered our product so it will fit in any PCIe slot. So the idea is to put it right in the server stack, where you need the encryption functions handled, whether they simply just be key management, meaning that we are going to securely generate keys and send them, locally across the stack here or wherever they need to go, because they may need to go anywhere. You may say, you know what, I want to serve those keys from my stack here to other sites or into Amazon, Azure, Google Cloud. You can do that. And that's what we're trying to allow you to do. Or you can sit there and say, I want to make sure that I can encrypt my data here rather than doing it, on the server, because I want to offload that from taking up compute cycles and perhaps adding additional latency if there are multiple applications, multiple VMs, vying for compute, on those platforms. We can do that too. And that's where it becomes a true HSM, where you're just sending the data locally to the card, and we're performing that operation for you. Okay. So the nice thing here is that we start to solve some of the problems because, like an HSM, we have all those capabilities. We're not worried about x86 vulnerabilities because we're not leveraging that to store and generate keys. We're not looking to run the encryption there. And that's one of the problems with, general purpose compute when you do serve keys to an application. And I'll show you an example here of like VMware running or any application databases, utilizing keys. When they do run, the keys are actually in the clear to be used by the application. So if there was an intrusion into the environment where intruders were there, you could actually get on these devices and actually see the keys. And if the keys are the same for, that database across your environment, which is often typical, now someone has the ability to utilize that key if they get into your environment to look at all the data on that given database. So that brings up the next problem we solve, which is, we want to have more keys being able to be utilized to better lock down that type of an approach, so that you can have a unique key for each instance of the application running, let's say. So that wouldn't happen. You can only breach maybe that instance of that application, but not let's say Oracle databases across your entire organization. So that allows us to do that. Okay, but the end goal is just run the encryption up into the card. So we're trying to provide you the right level of benefits that meets your needs. And we're stepping up here, though. We're stepping up from just offering an application to offering the application and a piece of hardware. So we're also incrementally increasing the cost here. So the nice thing about this, as I mentioned in the prior slide, is that with the microHSM, we are just going into open PCIe slots, and we're just drawing power from those servers. And when we communicate across the bus or across the network interface ports, that gives you that zero footprint. So you're not adding an extra device, into perhaps a tight data center, or you've got more and more people are seeing this, a cooling footprint, which is a problem. Again, because we're running on next generation, ARM core processors, we've drastically reduced the power draw and cooling per watt per CPU cycle by a factor of tenfold over your traditional server. So it helps quite a bit in these environments when that's critical and you're trying to save every penny or every bit of your cooling budget. I mentioned, there's multiple encryption operations that typically happen with HSMs. I realize when I say that, often people don't really understand what I'm talking about if they're not already deploying these solutions. So, we looked at competitor KMSs from the likes of Thales, SafeNet, Gemalto, Thales. They all became one company, so they're the leader. So they recommend that you use something like a TLS or an IPsec tunnel to send the data in to the HSMs across the network, and then have the keys there to decrypt that network level encryption. Then they perform the encryption options, and then they send the data back out. And if they send the data back out unencrypted, because you've sent it back to them to say, hey, out of, let's say, storage somewhere, I need to access this, then they have to put a TNS tunnel on the now decrypted data before they send it to the application. And the application side has to use the same TLS decryption. All right, so that creates a lot of steps there, very, very secure. We can do the same thing, but we offer the option, because if it's local in the same server or stack, that you don't need to do that and still achieve, a high level of security. And now you've freed up a lot of overhead from the applications from having to do all that TLS tunneling to encrypt and decrypt data. They may be coming in and out all the time. So that's just one advantage I want to make sure people understand. Okay, so what are the advantages in general of this type of approach? I've tried to say most of them here, so I won't go through all the ones we've talked about. But some of the advantages really come right from the ability of the SvKMS software itself. So the SvKMS software is very, very flexible. We can work with many applications. I'll talk to you about several in some of the use cases. But most of the database applications out there today, all the prevalent ones, we can handle. We can also encrypt and decrypt things like every VMware ESXi or every vSAN environment can be encrypted and decrypted using this approach with the SvKMS software. The nice thing too, as I mentioned before, is it's easy to deploy this application and then utilize it. Even like when I want to turn it on and off, if I want to do key lifecycle management, and let me pause on that for a second. What is key lifecycle management? You have keys, and in many cases today, I look at some storage environments. They say, oh yeah, we encrypt. We have one key. It never changes, and all our customers use the same key. Now, is that a great thing? No, because if you able to crack that key, get the key from one customer, you now have it and can go to any of those storage environments for any of those customers and now get access to the data. So that would be, a terrible situation. But there's plenty of products out there in the storage environment that's exactly what they do. Now, with key life cycles, you're saying, well, I'm going to have keys only exist for a period of time, and then I'm going to replace them, which sounds good. Okay, let's say every quarter or every month, I change up the keys that I'm using, and I'm running across all my instances. But let's say I put data away in storage somewhere for backup. Now I have to make sure I've always got the right key to be able to reopen that file. So that's called key lifecycle management. I'm setting up my periods of time when I want to change the keys and have the system do that automatically for me. But I also want the system to be able to know which key is which so that I can actually get the right data back, let's say from backup or store, and reuse that data very, very quickly. So the SvKMS is a superior job of handling all of that for us, which is a major headache that is now completely, what I would say, off the table. It's handled by the system, and people don't have to worry about it or worry about the management of it. And it can be massively distributed. We can put this software or these microHSMs, those instances anywhere that you have room for them. Okay, and then there's hardware-based root key protection, and this is really critical. As I mentioned before, there's been all kinds of challenges with the Intel environments in the past. And I'm going to let Dodson talk quite a bit about this. But it is a really, really important aspect to make sure that you understand those and how we're handling it across these solutions once we apply the hardware approaches. So I'll let him talk quite a bit about that. So there's quite a bit here. And I would say, if you're interested, I would say spend some time, get back to us, talk to us, and we can take you through some of these details, in light of our product, and then contrast them to some of the things that you may, already be using or are looking at using or deploying. The last thing I will focus though on is you want to have something that's very simple to use. People come and go in environments, and it gets very difficult if they have to be skilled and trained on all of this. And that's the last thing you want, is to say, I can't seem to be able to figure out how to access a whole bunch of data that was encrypted 3 years ago. I'm not sure what to do about it. So these things have got to be dirt simple, so that as people come and go, they can figure out what's going on without having to have some professional services person always on retainer to come back and help you figure these things out. Okay. So, as I mentioned before, the strengths of the software are pretty important. The way we've done it is we've got simple APIs that allow us to integrate to these applications. I've listed some of the top ones that people asked us about in the past here, so that we can encrypt and decrypt and or serve keys. We support the KMIP standard. That's the emerging standard. I shouldn't say emerging. It's been around for over 10 years, in heavily adopted. So that's a great standard for key management, but we're also backward compatible with prior, more proprietary approaches as well. And, we make it easy with our API to integrate to other applications as we go forward. So it makes for a flexible solution. So we're always adding more applications as customers request it. And it can be done relatively quickly. Okay, so I mentioned, the microHSM is a smart NIC. What the heck is that? Well, this is a network interface card on the right-hand side. So what we did is, we built a specialty version of this card to allow us to securely handle key management. We used ARM capabilities to do this, but it also gives us lots of CPU horsepower and memory, so that we can scale this up to serve thousands of keys a second, be able to go back and do all the lifecycle management things we've talked about, but also have the ability to go and do the encryption decryption right there inside the same platform. And then again, because we can leverage the rich API, we can handle multiple operations for different applications all at the same time. And I've covered the other points, but the key point people like about it is that it can slide into any given device that has an open PCIe slot, pull power from that, and it's off and running independently of the server host in which it goes into. Okay, so the next step up, though, of course, is, well, that's great, but what if I want the ultimate in having an appliance-based approach? And what if I want to make sure that the same appliance is there, so that maybe I've got the microHSM inside it and providing the encryption or key management functions, but I want to run my application securely as well and work it in conjunction. So that's where we step up to the appliance here. And we as ARIA looked at a lot of the vendors out there that provide server appliances. And one stood out clearly from the rest, and that was HPE. And with that, I'm going to turn over to Dodson to tell you a little bit of why that is, and I'll come back and talk about it, how it fits in our portfolio solutions a little bit later. So with that, I'll turn it over to Dodson.
Right. Thank you, Gary. I appreciate that. And good morning, good afternoon, everyone on the call. I'm going to talk today about HPE security and what we're doing from a hardware point of view to address some of the threat vectors that have gotten to actually kind of really come into their own in the last couple years. So could I get the slides advanced, please? Yeah, so we do quite a bit of work with the FBI on a lot of levels, but we're in pretty regular contact with them. We've hired a bunch of folks from the Bureau too into our security team, kind of looking at really what they've seen and continue to see from a threat vector perspective, and certainly from our own customer experiences too. But from really what I want to say here, from an attack vector perspective, I think the low-hanging fruit historically for hacking has been operating system holes and flaws, right? We all know that there were patches of the day, week, month, year for most major operating systems for a long time, but pretty much all the mainstream OSs have gotten very hardened over the last 5 years or so, to the point that they're really not the attack vector they had been historically. They've become pretty hardened, especially with the use of TPMs and things like that in conjunction with the OS to really assert legitimacy there. So one of the vectors that's become a pretty major target for hackers is firmware, right? And we've seen a number of cases in the last few years of actually firmware hacks being used where hackers put out there firmware that wasn't legitimate, and customers loaded it thinking it was either beta code or just special code they found on the web through Googling around, and came to find out that some of that firmware was actually pretty open in an attack vector. So we have developed some technology, and I'll talk about that in a bit. Certainly ransomware is a big piece of this too. I mean, I don't think there's probably a week that goes by that you don't read about some pretty major ransomware issues. And if you kind of look at what the insurance carriers are doing from a business continuity perspective, maybe 2 or 3 years ago, it was probably fairly easy to get insurance for data centers that would say, yes, if you're held up by a ransomware attack, they would help you and potentially cover the cost of outages and things like that. I think that you'll find that existing customers still have the ability to get that kind of insurance, but from my understanding and our understanding collectively as a company is that it's very difficult to get those policies today because the liability is very real and the number of cases of ransomware is through the roof, right? I mean, for every one you read about, there's probably 10 more, right, that happen on a daily basis. And I think the rest of the things here are all fairly obvious to those folks on the phone. So could we advance the slides? Yeah, so one of the design centers for our for Lion and Apollo portfolios is the concept of creating the world's most secure industry standard servers. So really, what can we do kind of beyond the basics to make sure that our hardware is as robust as possible from not only a reliability perspective, but also a security perspective? So we developed something called the Silicon Root of Trust. And on every server that we sell, we have an integrated management chip, which is our ILO technology, right? Our competitors use pretty much off-the-shelf BMCs, which are just that, off the shelf. They're typically designed by other companies and they buy them and install them in their product. We actually design our own BMC, for lack of a better term, but our own ILO chipsets. We're on the 7th generation of them. So we have a lot of core competency around ASIC design and also spinning ASICs as well. We don't own our own fabs anymore, but we still have our own ASIC designs contract manufactured. So when you buy an HPE server, the main BMC on that, the ILO chipset, is designed by us. As a result of that, there's an immutable root of trust, which means that anytime firmware is loaded on a system, we can tell right away whether it's genuine HPE or not, right? And if it's not genuine, right, if you've decided to load firmware from an untrusted source, that'll flag right away on the system. You can control the behavior that occurs when that's discovered, right? The system can reboot automatically. The system can revert to known good firmware. So when the system ships, it has known good firmware on it, right? Because it comes from our factory. So you can just automatically revert to the last known good firmware on the system, or you can simply shut the system down, right? So you've got options with that. And that's not a separate billable feature. That is a standard part of the offering, right? That's just part of the server itself. For customers in the federal space that need a higher level of checking than that, we do have the advanced feature sets for ILO. And one of the features in the advanced set is the ability to scan for firmware legitimacy on whatever interval basis you want to. So hourly, daily, etc. So again, if you're going to load firmware that doesn't require a system reboot and you want to have that checked on a very persistent basis, that's possible. That'll plug into some of the NIST frameworks as well. Config lock is also a pretty big deal too. So we have this concept that when a server is built or manufactured, it can be locked with a password that is user specified at the time of build and has to have that password in order to boot. So design that the security during the transport process can be maintained there. If a server's opened or anything changes with the server itself in the time of transport, again, as soon as the server's first booted, that'll be flagged and you'll be notified that that's happened. So really, those are kind of some pretty big features to guarantee the veracity of root of trust. We've also developed one-button secure erase as well. So for servers that are being decommissioned, there's always that question of what happens to the data if I do erase it? Can it still be recovered? Things like that as part of data center lifecycle management. And we now have one-button secure erase, so we can completely erase a server all the way back to bare metal and not have that be able to be recovered. That's a pretty big deal. And self-encrypting drives have been around for a long time. We also, in addition to self-encrypting drives, we have the ability to add some security software to our array controllers called Secure Encryption, and that will encrypt the data at rest so that if you have anybody that takes a drive out of a server, they're not going to be able to do anything with it. It's all hashed and secure. So being able to kind of protect things from happening at the point of ingress is a pretty big deal. As I mentioned, detecting compromised firmware is a pretty big deal. Runtime verification being a big deal. We also, of course, from the physical security standpoint, have some other features too. We have intrusion detection as an option on servers that you can actually flag. If a server's been opened at any point, you'll be notified. If the server's up and running, you'll get an immediate alert. If it's not up and running, the next time it gets connected, you'll be alerted that it's been opened. And kind of that whole concept of a verified boot is a very big deal. So that's definitely a calling card for us. We'll talk about that in some more detail. And of course, being able to recover things in a secure manner is probably the biggest deal of all out of all of these. And again, the concept of if I get my firmware compromised, I can automatically just revert back to a known good version. Pretty helpful. Also, the data collection that goes on, we have as part of the ILO system, we have what I'll call an in-flight recorder or hardware log system that keeps 7 days of logs at least on the server itself. So if you think you've seen an event that warrants further investigation, that's stored in non-volatile memory that can automatically be uploaded forensically to us every day. If you wish to do that, that's also a free service. So if you're comfortable sharing the data from your logs with HPE, we have a microcloud that they get loaded to in an anonymized fashion where we don't get information about your IP address or host names, but literally can automatically apply a lot of AI to logs to see if there's something from a hardware perspective that needs to be remedied, or if there's been a security style event, we can notify you of that as well. Yep, so I talked about configuration lock, I think in some detail already, but that has been a big calling card for us in terms of both manufacturing and being able to secure servers at the point of manufacture, also from site to site. So clearly there's some pieces that we may not be doing at our factory as part of server integration. So again, from a reseller or staging point of view, servers can also be locked, or even just customers moving them site to site if they're going into a third-party company's hands for transport. Again, that concept of being able to lock and unlock only with the password is pretty helpful. And we've noticed that also will help customers who are concerned about having substitutions done in transport. So we had one customer that was particularly concerned that they had RAM stolen out of some of their servers in the course of transport and or replaced with other kinds of memory. And this again will help prevent things like that from happening. Yep, and I talked a lot about ILO already, but again, it all kind of comes down to there's a dashboard that you can look at all this either on the server itself or remotely into a console type environment. We plug into pretty much every major console out there. ILO uses an API called Redfish. We used to have sort of a more proprietary approach to ILO and getting data from it, but with the right permissions, you can do a lot with the Redfish API, which is a standard based way to query the ILO itself. But again, we can do a security audit for fundamental things right on the server as part of ILO to tell you, hey, these are things that are configured that probably should be turned off, like IPMI, for example, probably should be disabled over LAN as a best practice. There's some customers will still use it. They don't want to disable it, but if it is enabled, you will get a security warning to say, hey, consider an approach to get rid of that in your environment because it's inherently not secure. And things like that. So we have the ability to kind of monitor that and just kind of report it to make sure that all servers are in compliance from a policy point of view. And if you're working in an environment where there may not be a defined policy that covers all of these things, it can at least guide you toward best practices. May I have the next slide, please? All right. Thank you. Secure erase talked about already a little bit, but again, that has become a very big deal. When you look at the statement of volatility, so what's required literally to fully remove all data from a server that could be stored in NVRAM, et cetera, you can see that the statement of volatility for a typical server can be 15 pages or more. So a lot of steps, and being able to kind of concatenate all those steps into one command or into really just one way to do it. We now have one button secure erase. So literally go into the ILO, secure erase, tell the system 3 times that you really want to do this because it's not revocable, and then go, and the system will be cleaned. It takes a couple hours, but it's certainly a lot easier than doing the prior way of following every step in the statement. It's all just done automatically. Yep. So again, those are really kind of our big calling cards of things I've talked about. The other thing worth mentioning here too is that we do have secure supply chain. So we're very focused on making sure that genuine components are in our supply chain. We have the ability for customers that need this level of security or this level of supply chain compliance to actually build a number of ProAlliance now in the United States, right? So if you have an opportunity where it makes sense to do a server build literally on US soil, we can do that in Chippewa Falls. There's a special SKU for the server. It puts a T behind it. And so we can actually do those trusted builds actually right in the US if needed for servers. I also too talked a little bit about insurance already too. And again, this is becoming a bigger and bigger deal. I don't know if anyone on this call has direct experience with this, but really kind of proving to insurers that your environment meets security requirements is becoming a bigger and more arduous task all the time. We worked with Marsh to develop our products in a fashion that is compliant with our Cyber Catalyst designation, which means that, again, we've proven to Marsh McLennan, which is a broker for multiple types of cybersecurity insurance, that our methodology is pretty solid for preventing ransomware vectors from attacking the servers from a hardware and firmware point of view. So if you are using let's say Cyber Catalyst compliant hardware, you can probably get a better price on insurance from a interruption perspective. So we have that designation both on ProAlliance and also on our Aruba-based firewalling product as well. So good story overall with security. It is the design center for our Gen 10 and Gen 10 Plus products. It will continue to be the design center as we move forward to next gen as well. So that's been a fairly big differentiator for us and has actually helped a lot of customers avoid downtime. We have a number of case studies showing some medical systems that used our hardware and had a mix of other brands, and it was our ProAlliance that were not compromised in a multi-vendor style attack. So pretty good story there. So thank you, everybody. I think we can, and I'll hand this back.
Thanks, Dudson. As you can see there, HPE has really done a really good job of providing answers to all the problems that I was surfacing earlier in the conversation. So not only can we secure data, we can actually secure the environment in which the applications and everything execute within. And this is just built in. It's wonderful. So that's why, we offer that as the ultimate appliance approach here for us, so that we have that ability. And Dotson's exactly right. The insurance providers out there are a lot more inquisitive as to your processes and what you're doing inside your business in order to make sure that they're writing policies that assess your risk, and then you get a premium based on that risk, or you just get denied. So that's happening. So across the board, there's a lot more to be said there. It's not just covering this area, but security practices at large are being analyzed by these insurance providers now. So with that, let's get into a few use cases. I'm looking at time. I'm going to try to go through these fairly quickly. But one thing that we've been asked quite a bit about is, and I'm a little surprised that there's a lack of awareness out there, but VMware provides an interesting way to secure your application's data output. It doesn't seem to be a feature that as many people as I thought would know about it that have VMware environments. So I'll just step through that a little bit. As of vSphere 6.5, VMware added this ability where their applications, their ESIX application at the VM level can actually encrypt the data output. All they need is to vServe keys. And this works in conjunction with their vCenter application. But what they require here, and they show that gray box on the top, is they need some kind of third-party key management server function to provide these keys. They're following best practices, and the keys can be provided down to vSphere, and then vSphere will provide them down to the individual VMs requesting them. But they do need to have this full key management function, including the lifecycle management of the keys that I talked about earlier. So it's pretty important. Okay, so that's what the need is. So how do we fit into this? So on the left side, kind of showing you the VM environment. We've got an ESXi that wants to encrypt its output, and it's basically asking vCenter for the keys. And vCenter has already been set up through a simple configuration to be able to provide those keys. But in turn, vCenter is looking for the keys from that key management device, and that is us. Now we can do that and run that KMS as software on a server. We can run it off of the HPE server we showed before. We could run it off our SmartNIC microHSM. And in this case, we're just securely serving keys. And we recommend that if you've already got servers, you don't want to buy another server and spend a few dollars less, the microHSM may be a perfect option for this, because we're just serving keys into that environment. Okay, so in that case, basically vCenter is requesting encryption keys from the ARIA KMS, and the ARIA KMS responds with the keys. So you can kind of think of this as a one-time transaction. Okay, I've got to go in and encrypt data, but we got to keep track of the keys we serve for that request. And because if a request comes back in for that key again, because that data was put away into a storage bin, and then every month the keys were being changed, we've got to basically index those keys so that when the request comes in and says, I need, this key, we have that and can serve it right back to them. Because vCenter is not going to, if it gets blown away or, its cache runs out, it's not going to have all those keys in it, nor would you want it to. So they rely on us to store those keys securely so they don't have to. And that's not a point of security vulnerability. So that's what's going on here. We're serving the keys. We got to serve them quickly so we can send them out to, some environments have hundreds, some have thousands of VMs. And we may only have a few of our network interface cards, in those environments, providing all that key management for them. Okay, so the nice thing is, I mentioned before, this is well documented in vCenter, and we actually have a video on our website at ariacybersecurity.com. You can actually see a little video of us actually setting this up in vCenter and setting our site up, and it can actually be done in 4 minutes. The video actually runs 4 minutes long. So it kind of shows you that it's not very hard to do, and we encourage people to do things like this, because this is the way to actually start to protect your data and do it in a way that's a whole lot more secure. And you'll see more requests coming in as we talk about insurance providers as to how you do this. They just want to know what you're doing. And if you can sit there and say and mention these best practices, chances are you're going to get insurance and you're going to get a better premium than the next guy. So I mentioned before, well, wait a minute, if I've got large environments, how many cards do I need? How does this work? So in this case, I'm just showing, one key coming out of one card, going to one VM, but I've got multiple VMs. Well, that's no problem. We're serving multiple keys. This is great. But I'm thinking about this and like, okay, if I've got 100 VMs that I need to run this from, doesn't that microHSM become that single point of failure? The answer is yes. We've done our best to make sure that those things are built well. Typically we get 10 plus years out of a card in life cycle. Don't get many returns or requests for repairs. So we've done a really good job, but best practice says you should have high availability. So what we want to do is add multiple cards here. Usually that's when things start to get really complicated. Like, okay, which card's got what keys? How's it being offered to the devices when they come back? What if the card I was talking to doesn't respond? So we've hidden all that. So there's basically a master-slave relationship going on between the cards that we have in a group, and they provide all that for you. So if one card goes down, you don't even know the difference. It's because it's being served by 2, 3, 4, 5 cards. And we recommend at least 3 as best practice. Okay, so that's built into the functionality to provide us that HA option for our KMS. Okay. We talked about simple applications like bring your own key, all right? So we showed it going to VMware environments, but what if I don't have a VMware environment in my premises anymore? Maybe I've got that over in Azure, AWS, Google. We can do the same thing. We suggest, though, you don't have Amazon, Google, or Azure generate the keys because they're generating a key for you, but they generated it themselves. And that's not industry best practice because you want to control the generation of those keys. It's a little far-fetched, but here's one example. If, for instance, you were serving keys into other regions of the world, and let's say it was Germany, and the Germans wanted to get access to your data, they could submit it to Amazon or Azure and force them to give access. If they did, and you had already provided your own keys here, there's no way that Amazon or Azure could be coerced into opening up that data for the German authorities. This sounds far-fetched, and you still start thinking about terrorism and what's been going on. So that's a way for you to control so that you're making sure that you're dealing with authorities on your terms, not having some third party do it for yourselves. It does sound far-fetched, but it's not too far from reality of what can happen. So that's just one example, because you want to know and you want to control it. And then there's other concerns is, well, how good are Amazon and Azure actually protecting the keys that they generate for you? And you have no visibility at all into that. You just have to trust them. So this is good practice. And again, it doesn't take much in the way of hardware. This could be sent securely over the network, and you're off to the races. We talked about bring your own encryption. Most people don't like bring my own encryption. The way that I'm thinking about this is the typical application is people are like, okay, I want to generate some data and then back it up into some cloud service. I use S3 as a good example, and AWS does a good job of this. They don't charge you much to send data into the cloud. The only time they really charge you is when you want to pull it back. But if you really got to pull it back, you really need it, and you're probably happy to pay. So it becomes a low-cost way to deal with things like backup and setting them up on your own or with their services or any third-party service that provides such backup. But what's happening here is we're actually encrypting the data before it leaves your premises, and then it's on its way into these services or whatever third-party service that you have. And again, it's a low footprint on your premises to do that. So again, it's a step up in good practices, but allows you to make sure that you're securing your data in the backup form, and then you're also able to pull it back and uniquely decrypt each volume. So in case one volume was hacked, it probably wasn't hacked to the next backup because those instances were kept securely separate and have different keys to get access to the data. All right, so and then the next step up is to use the microHSM in your own data centers to encrypt your files locally. Covered this quite a bit, so I won't dwell too much on it. All right, so how do we stack up versus the competition? I just have one eye chart here for you. Sorry about this. But the idea here was with ARIA working with StorMagic was to make sure we solve a lot of these problems that other solutions out there, haven't fully addressed. And I've tried to cover most of them, by making sure that we can deal with these hybrid examples here of the use cases, and let you pick the right solution, the right price point that meets your need, and not get tied down to something that's very complicated that you have to then be vendor locked in, or have to have professional services to have help deal with it. And the point here is, you leverage our type of hardware approach. We start to see scalability, and if you want to step up in level of security, we've got those options all the way for you. All the way through the service suite here of the 4 options that we're providing. So hopefully that makes some sense. I won't dwell too much on that because I want to make sure I have some time here left over to open this up to Q&A. Okay, we got one here. Okay. I'll give this to Dodson. You mentioned silicon root of trust. How proven is this? Does it really solve some of the problems we see with the Intel environment?
Yeah, so it's pretty proven. And unlike a lot of our competitors, it's not software based in the sense that a lot of our competitors are taking shelfware BMCs and loading their own code onto the BMCs, right? So that is a pretty big difference with us. The actual root of trust, if you will, the keys are immutable because they're built into the silicon that we develop. So the root of trust has never been hacked and is really not capable of being hacked for a lot of reasons. But we have a pretty good story there, unlike our competitors that, again, are using firmware in their own, not in their own, but in shelfware BMCs, where that firmware could essentially be potentially altered. We're not in a position where that can happen with our products.
Oh, good. I also have one here that is the solution FIPS certified? And I will say yes, the software is FIPS 140-2 level 1 certified.
Same with the root of trust too. Yep.
Yeah, excellent. There also was a question that came in, I guess it came from your slides. What is common criteria?
So it's another method of certification.
Right. So that's from our side, that's a certification that usually you get out of the federal government, requiring you meet certain criteria as to how the platforms are produced so that they are secure. And that's what HPE is providing us. Trying to see what else we got here. There's a question of what applications we support. I kind of suppressed that. I'll share back my screen here to show the applications.
While you're getting that teed up, Gary, we have had another question come in over the chat asking about the availability of the solution, whether it's available worldwide or just in specific geographies.
Okay, yeah. So this solution is available worldwide. So there's no restrictions on the solution being offered. I know that often comes up as well about the encryption, but there are no restrictions here with the encryption that we are using. So here's a list of the applications. It's what do we have today? There have been a few additions, I believe, to this list, but it's currently what I have in slide format. Covered several of these things. You'll see the databases there from the previous slide, as well as others. And one point is, I glossed over it. We talked about vSphere, but we also can encrypt vSAN output as well. There was a question here that said, you went through 4 options. What are the differences? Okay, good. I have this in my backup here. The 4 options were the key management as a service. That's where we serve keys out of a cloud and offer that to your applications that can take it. SvKMS is the application that provides the key management you can run in any server in your environments. It does all those features that we talked about. So it's a great approach. The microHSM takes it one step further, runs that functionality inside SmartNIC, providing that higher performance, higher level security, lower cost per compute, and make sure that you have high performance for your applications. by offloading encryption. And then the last is the KMS appliance. As we went through that, that becomes the ultimate environment, not just to do your encryption, but to run your applications and provide the ultimate security. And you kind of can see each step here, does increase functionality, value, and we do charge for that value. So hopefully that covers that. I know we're running out of time here. I saw one question earlier. I think I saw it pass my, insurance. How does this save money? Dotson started to cover this quite a bit. I just add to what he said. He mentioned that it's difficult to get ransomware insurance in particular, especially in light of everything that's happened. So I don't know if you want to add anything to that.
Yeah, I mean, I think that I'm talking here specifically about cyber interruption insurance. So a lot of organizations have that. Like if your organization's held up with ransomware and you can't operate for several days, that business continuity or business interruption insurance is designed to replace the revenue that you would lose from being unable to produce said revenue over the period of time. And how does it save money? The fact that our products are Marsh Cyber Catalyst certified means that because you're using our products in environments, the carrier can offer you a discount. We're not saying that will absolutely happen, but depending on the type of insurance you buy, the fact that we have that Cyber Catalyst designation is not a minor thing. That takes months to get and all kinds of testing and certifications to get. But using our hardware can provide you with lower insurance premiums for that type of insurance, potentially.
Yeah, and I would just add to that you want to have good cyber hygiene across the board. We sell other products that help address this as well. Encryption is one area that insurance companies will ask for. Also, are you doing a proper job of securing the rest of your network and your environment? What happens is you will get when you go to fill out your insurance, they'll ask you a whole series of questions in detail, and then they'll come back and either give you a policy and a price based on your answers. So one thing I will caution is it's tempting just to say, okay, well, I'll just lightly exaggerate on some of these things. Maybe we don't have all these full protections in place. However, if you do that, they have forensic teams that come in usually when you have been breached, you file a claim. And they're going to want to see if you actually have all those capabilities. You had them in place. If you didn't, you're not going to get paid. And that was kind of glossed over, but that's changed dramatically over this past year. In fact, we talked to one insurance provider just on ransomware alone, their premiums increased 4x if you could get a premium. So this is something to talk to your insurance agent about quite a bit. Make sure you have the right coverages in place, and make sure it was just mentioned that you have everything you need to make sure you have business continuance coverage in case you do get hit. All right, I think we're just about out of time here. Well, I'd like to really thank everybody for their questions, and thank you, Dotson, for your great presentation.
Thank you, everybody.